Dear participants, welcome to today's webinar organized by the EU projects Trusts and Safety on the topic of privacy preservation in data markets. My name is Nina Propanton and I will accompany you through this event today as your moderator. For your information, this webinar will be recorded and shared on our YouTube channel afterwards. Before we jump directly into the topic, I would like to give you a short outline of what the two projects Trusts and Safety are about. TRUSTS, which is the acronym for Trusted Secure Data Sharing Space, is an innovation action funded from the European Horizon 2020 Research and Innovation Program. The project brings together technology providers, data providers, research institutions, and multipliers. Its goal is to create a secure and trustworthy European data market, as well as a data market federator for personal and industrial use by interconnecting different user groups and providing generic functionalities for innovative applications and services. Safety, which is the acronym for Safe Data-Enabled Economic Development, brings together partners from cryptography, data science, business innovation, and legal domain to focus on improving security technologies, improving trust, as well as on the diffusion of privacy-enhancing technologies. Safety provides a set of tools to facilitate the assessment of data value, thus incentivizing data owners to make use of the scalable cryptographic protocols developed in Safety to create value for their companies and their clients. Well, that actually brings us to today's agenda. In a few seconds, Ioannis Markopoulos from Forthnet will give you an introduction to the GDPR roles. This will be followed by Alexandros Bampoulidis from Research Studios Austria, who will discuss with you actual and potential privacy risks. In the second section, we have Lukas Helminger from Center talking about trust by design. At the end of today's session, we will have a Q&A session. So if questions arise during the talks, please make sure you remind them later or drop them in the questions section here in GoToMeeting. So that already opens the floor for you, Ioannis, on the GDPR roles.
Thank you, Nina. Thank you all for your attendance. Well, this first part will be a short one, but it will put the framework. In both projects, Trust and Safety, we are not only analyzing algorithms and propose solutions, but we want to put them in the business context, in the entrepreneurial context. So we have to take into account all the regulations and see the roles within the entrepreneurial framework in our businesses practically, and see how we can accommodate processes and solutions. So we have all this 360 perspective in our proposals for both projects. And to go straight away on the regulation, we all know the General Data Protection Regulation that stands since, it is in force since last year. And it's practically a horizontal legislation that touches upon all enterprises in order to guide the management of the private data usage and control. So it appoints specific roles on how data management will be done within enterprises, organizations, and so on and so forth, and also clarifies the responsibilities and what we need to do when a need for data management arises. So practically, we have two main role categories, the data controllers and the data processors. And the data controllers, to start with, is those who are really accountable for the data management processes. We can proceed in the next slide, please. Thank you. So just to understand a bit the role of the data controller, the data controller defines the purpose for the analysis of the personal data and the means to do so. So the data controller within a company defines all this framework. Data controller is the company itself that really wants to analyze or manage personal data and appoints the responsibility to specific named employees. So these employees, along with the company processes, have full control of all the data, and of course they are respectively accountable. Should more than one companies jointly have the ability to or the willingness to control data or manage data, they will become joint controllers. In business environments, it will often happen that more than one companies or units or companies within a group have the need to jointly control and analyze the data. For instance, multiple CRMs from various companies in a group may need to analyze clientele profiles in order to make joint offers. So they will eventually become joint controllers. And of course, the employees that really do the analysis, tech people that poses the question in the databases or do the specific analysis, following the instructions of the controllers, are called data processors. Data processors do, I would say, the end mile job, but the full responsibility always lies on the data controllers. So by this brief presentation, I would like to give the floor to the forthcoming presenters, of course, through Nina, who are going to present vertical solutions on risk management and data sharing, and of course, data exchange possibilities, respecting, of course, the GDPR framework. Thank you very much, and I'm willing to take any questions now or at the end of the session. Thank you.
Thank you very much, Ioannis, for the interesting introduction. I would like to remind the participants that we will collect the questions and answer them later on. So this is why we are now proceeding to privacy risk in data sharing. And Alexandros, the stage is yours.
Thank you, Nina. Hello, I am Alexandros, and I am a researcher at Research Studios Austria. I will talk to you about the privacy risks in data sharing, and I will demonstrate to you the related part of the safety personal data demonstrator. Next slide, please. Personal data is data that contains information about individuals, and it is the driving force behind research and innovation in many industry fields. Trace data, for example, being used for the optimization of public transportation, and online customer purchases for marketing purposes are some of the benefits of collecting and processing personal data. However, such data contains private, sensitive information about individuals. Previous slide, please. Such data contains private, sensitive information about individuals that they might not be willing to publicly share. And the data controllers are responsible for protecting the individual's privacy contained in their datasets before sharing their data. Next slide, please. Here is an example of personal data, zip code, age, and nationality. Could anyone from the audience tell me what is wrong with it with regards to privacy? The problem is, previous slide, please. The problem is that everyone is uniquely identifiable by their attributes. For example, if an adversary knows the zip code and the age of a person, then the adversary identifies this person. Because there is exactly one person living in 13053 and is 20 years old, and exactly one person living in 13068 and is 29 years old, and so on. Next slide, please. So these attributes that do not directly identify individuals, but when combined can serve as unique identifiers, are called quasi-identifiers, for short QIs. In fact, according to a study, 87% of the US population is uniquely identifiable by the combination of their zip code, date of birth, and gender. This study also demonstrated how this information can be used to breach the privacy of individuals. In this figure here, you see two semi-publicly available datasets, a voter registration list, which can be purchased for a fee, containing personally identifiable information such as name and address. And on the left, you see medical data from a hospital, typically given to researchers. An adversary possessing both datasets can easily find out sensitive information about individuals that they would not publicly share, such as their medical conditions and medications. Next slide, please. And what about this case? Here, there is no individual uniquely identifiable, but by their QIs. And we also have an attribute that an adversary would in general not possess because it's private. Could anyone guess what the problem is here with regard to privacy? The problem is in records 9 to 12. If an adversary knows a patient in their 30s living in a zip code starting with 130, then the adversary knows that this patient has cancer. Next slide, please. Privacy risks exist in different kinds of data. In 2006, AOL released the research logs to the public for research purposes, of course. These search logs contained the complete search history of all their users and the documents they clicked. Of course, the users were represented by an integer identifier only. But as you can see in this New York Times story, an individual named Thelma Arnold was identified. Her search history tells the story of how she wanted a dog, that she got one, and that she was looking to give it away to an animal shelter. Now, this story is rather innocent and not privacy sensitive, but as you can imagine, such data contains a lot of privacy sensitive information. Next slide, please. And here we have location data, the time and place where individuals have been. What do you think is the catch here with regard to privacy? Well, a study.
If you have thoughts, please drop them in the chat so that we can pick up your thoughts on this.
Yes. Well, in this case, a study showed that 4 points of location and time are enough to uniquely identify 95% of the individuals in a dataset consisting of 1.5 million individuals. This means an adversary with little information only can find out the complete whereabouts of an individual. Intuitively, think of this, that you are the only person in the city that lives in your home and works at your workplace. So theoretically, if your neighbor gets his hands on this data, then he can actually find out where you have been all the time. Next slide, please. And in 2006, Netflix released their ratings as part of a competition. Back then, it was ratings from 1 to 5, not like it is now, like or dislike. And yes, the data consisted of the information you see here, a movie, an integer identifier of a user, a rating, and the date of the rating. A study shows that up to 99% of the users could be matched to their public IMDb profiles if they, of course, reviewed a movie, even though the IMDb ratings are from 1 to 10. This could lead to an adversary to find out the movies that the individuals rate in private and that they did not rate publicly in IMDb. Certain movies, so the catch here, the privacy catch here is that certain movies are linked to political and religious views or any other privacy sensitive information. Intuitively think that each one of us has a very unique taste for movies, and we are all uniquely identifiable by our tastes. Next slide, please. To mitigate those privacy risks, the data needs to conform to privacy models. There has been a lot of research introducing privacy models which specify the privacy principles a data set needs to conform to. To conform to these principles, a data set must be distorted, meaning that its real values must be changed. There are two most prominent ways to do that. One is distorting the values of the dataset and share it. And the other way is to not share the raw data, but rather expose it and allow it to be queried by outsiders and then distort the responses. Next slide, please. Here is an example of the first way, generally referred to as anonymization. This is the dataset from the previous slides, the original on the left and the distorted on the right. Now, in the distorted version of the dataset, no individual is uniquely identifiable by their QIs, zip code, age, and nationality. And also, no group of people is linked to a specific disease. This is possible because the last digit of the zip code was removed. People were grouped into bins of above 40 or below 40, and the nationality completely removed. And thus, we have this private data set conforming to a specific privacy model called L-diversity. Next slide, please. And here is an example of the second way, referred to as differential privacy. Here we have a location dataset with the location of users, to which we send the following request. Give me the locations of people between the age of 20 and 30. The response is the number of people per location. On the left, you see the original and the non-distorted response. And on the right, you see the distorted response. So such a distortion creates a doubt to an adversary on whether any particular individual was used in the computation of this particular result or not. Next slide, please. Now I will proceed to demonstrate the related parts of the public personal data demonstrator of safety. And I'm going to share my screen now. Okay. Are you share? Do you? Okay. Great. Thank you. So the personal. Sorry. Sorry, do you still? Okay, because I got to that. Yeah, so the personal data demonstrator can be found under the address demo.safety.eu, and every part, and every part comes with explanatory videos. In this in this presentation, I will only show you the related part to the privacy risks, called the anonymization risk analysis. I go to proceed demonstrator, provide data for external analysis, and then to the related application. So in this case, we have demographic data consisting of 9 attributes that you see here. And the first step would be to select the attributes that are also quasi-identifiers, QIs. We select them all because they're all quasi-identifying, and we click Analyze. The output plot, the result of the analysis, is the following point plot, and each point in the plot represents a unique combination of QIs. What I mean with unique combination of QIs is this. For example, a data set with 3 QIs, zip, date of birth, and gender, has the following 7 unique combinations of QIs. Now, the x-axis represents the number of QIs that are in a specific combination, and the y-axis represents the probability of de-anonymizing an individual. In other words, the y-axis represents the percentage of the individuals that are uniquely identifiable by a specific combination of QIs. And when mousing over a point, you can see the probability of the anonymization and the respective combination of QIs. Naturally, the plot can be zoomed in and explored, and can be zoomed out. For example, there's no one uniquely identifiable with 1 QI, and so on. Now, the next step, in order to mitigate those risks, in order to make everyone not uniquely identifiable, in other words, have this probability reduced to 0, is to k-anonymize the data. So k-anonymity is a principle that states that every individual should have the same QIs as k minus 1 other individuals. Once selecting the k, we can click the button Anonymize, and you will be redirected to a new page where you can download the anonymized data. And this algorithm that we have here introduces null values wherever it is necessary to conform to the k-anonymity privacy model. Like, as you can see here, there used to be a value, a real value here, and here and everywhere that is possible. And this concludes my presentation, and I give the floor back to you, Nina.
Thank you very much, Alexandros. I will try to share my screen again. Just 1 second. Is it already working? Great. So now we will proceed to our next session with Lukas Helminger from Center on trust by design. Sadly, Lukas can only be with us by a microphone. There will be no picture of Lukas, but I'm sure it's gonna be fine still. We hope for your understanding, and that this is the moment where I give the word to you, Lukas. Lukas, does it work? We would like to ask you for 1 second here for the technological aspects. Lucas, I can see that your microphone is on, but I cannot hear you.
Hear me now?
Hi, now I can hear you. Great.
Perfect. Thanks, Nina.
Okay, so I will get to work.
Lukas Helminger, from the Know Center and work as a researcher in the data security area. My focus is on privacy preserving data analytics. And you all know that any business can hugely benefit from analyzing its data. And you saw now a talk from Alex how to protect this data. But what if you think about what you could even do if you were able to analyze data across different businesses? And that's what this talk is about. So we will dive into how emerging technology, multi-party computation, or in short, MPC, can create new business opportunities for you. Let's talk about Jeff. He owns a bar in the historic center of a city. Let's imagine that Jeff and other business owners unite to perform a marketing campaign. After the completion of the campaign, they are curious if it was a success. Therefore, they are looking at the sale revenues before and after the campaign. But I think you can understand that Jeff hesitates to disclose his revenue to other bar owners. What if there is a way to compute the sum of all revenues without disclosing the individual ones? And indeed, using an MPC protocol would solve the issue. More concretely, the business owners would be able to securely compute the sum of the revenues without leaking their individual revenues. From this example, I hope you can already see the potential of MPC to create new business opportunities. Namely, whenever on the one hand there is an economic benefit in sharing data, but on the other hand, the impacts of disclosing the data is too great of a risk. Such risk involves violations of the General Data Protection Regulation that you heard in the beginning of this webinar, or revealing inside information about your business. Can you think of valuable data in your own business that you're afraid to share? If yes, you probably found the first opportunity to use MPC in order to get more out of your data. And I'm sure that if you think for a little longer or together with your partners, you easily come up with many more use cases. Now let's take a closer look at the technology behind MPC. The aim of MPC is to enable a group of participants to jointly compute an agreed upon function without revealing their private input to the other participants. Note that with MPC there is no need for trusted third party, therefore trust by design. You could say MPC provides this as integral part of its definition. And it's also one of the pillars of the GDPR. So there, one principle is that your solution should give you privacy by design. To make the concept of MPC more practical, I will show you the idea of how it works. For this, you don't need any technical knowledge. We're coming back to our example and to Jeff. Remember, he wants to be part of the computation of the combined revenues without revealing his revenue. For simplicity, let's assume there's only one additional business, a bar that is owned by Alice. Now Jeff and Alice would like to compute the sum of their revenues without disclosing their input. How is this even possible? With a concept called secret sharing. This concept is the most popular one to realize MPC protocols. The secrets in our case are the revenues. Secret sharing can roughly be divided into 3 steps. Let's walk through them. At first, the creation of secret shares. Therefore, imagine Jeff's revenue for the last month is 30,000 euro. He now splits up his revenue into 2 shares. Say share 1 is 12,000 and share 2 is 18,000. On the other side, Alice does the same procedure. Say her revenue is 35,000. Then she maybe splits it up in 90,000 and 16,000. The second step is the exchange of the shares. This means that Jeff gives away 1 share of his secret to Alice and vice versa. The third step is the actual computation. Jeff adds his own and Alice's secret share together, which leaves him with 28,000. Alice does the same and gets 37,000. You see that those two numbers on their own don't give any meaningful information. If Jeff and Alice now want to know the sum of their revenues, they only have to add their values, arriving at the number 55,000, which is the correct result for the combined revenues. Of course, Jeff could now subtract his revenue from the result and arrive at Alice's revenue. However, this is due to the simplicity of the example. If there are more businesses involved, then there is no way for Jeff to compute Alice's revenue. After we now have a deeper understanding of MPC, I would encourage you to ask yourself again the following questions. Do you own sensitive data in your business that until now you were afraid to share? If yes, first think about how could you benefit from sharing the data. That means, what could you gain? Second, ask yourself who are possible business partners in your computation. Once you have answered all those questions, you are in the best way to create new business opportunities with the help of MPC. And now I want to move to the demonstrator, so the one that you have already seen with Alex. We have also developed a special protocol that uses MPC to create a new business opportunity between two companies. And maybe some of you could share the demonstrator now.
I will share my screen for the demonstrator.
Perfect. Yeah. So here we have the business opportunity that two companies, for example, a telecom company and a bank, want to find out the intersection of their customers so they can maybe make a targeted marketing campaign or do some cross-analysis. And how you can do this in a privacy-preserving way with a protocol that is called private set intersection. And this protocol comes from cryptography, but you don't need to know anything about cryptography to follow what the protocol does and what it offers. It allows two parties to jointly compute the intersection of their datasets. Thereby, neither party learns information from the protocol execution, except for the elements in the intersection. For example, take Alice and Bob. They want to compute the intersection of their smartphone contacts, but without revealing any other contacts that are not in the intersection. And you see on the screen the names, and we say here that Alice contacts are Tom, Veronica, John, Doug, Anna, and Tim, and you also see the contacts of Bob. The output of the PSI protocol would be Anna and Tim, but important, Alice would not know that Walter, Leonard, and Penny are contacts of Bob, or vice versa. However, I think it's not intuitive how this exchange of information can be performed in a privacy-preserving way. So I'll walk you through. Naively, without regards to privacy, one would just exchange the datasets and look for matches. But of course, this would leak all the contacts. Therefore, we encrypt the datasets before exchanging it and then use a SMUT method to compare the encrypted data. And if you look at the use case that was developed in SafeDeed and is now further developed in TRUSTS, we can see the picture a bit better. We have two companies that want to find out the intersection of their customer relation management databases, based, for example, in SafeDeed's case, on the zip codes. Each company holds a dataset with the list of zip codes corresponding to the customers. The companies begin the protocol by encrypting the list of zip codes, each with their own private key, as you can see with the red and the blue key. Next step is the companies exchange the encrypted lists. This is not a privacy risk, since the other company is not in the possession of the private key. Therefore, it cannot decipher the list. Now both companies encrypt the just received lists with their private key. Then they exchange the double encrypted lists. So you see these locks, the blue and the red lock. And now they can compare the lists. And each match indicates that they have a zip code in common. More precisely, the index where this match occurs tells you which zip code they have in common. The common entries then get decrypted with the respective private key. The PSI protocol that is used in this demonstrator uses more sophisticated methods for performance reasons, but the high-level idea is similar. The protocol can not only handle zip codes, but you could, for example, if your business case is you want to intersect on the customer names, this is also fine. It's just you have to have a data string that you can match. And in Trust, we extend this protocol even further so that you don't only get the intersection, but you can send also associated data from this customer relation management database, so the other fields that are connected with this customer. And maybe Alex can now show you how you operate this demonstrator. It's very easy. So all the magic happens behind in the software. You just choose a data set you want to intersect and a company, a partner company you agreed on, and then you run the intersection. And the result that you then see is here are the zip codes that both companies have in common, but you could imagine every possible field that could, the customer names, the age, or something like this. And in Trusts, we are currently on the way that you can also see then the associated data to this customer. I hope you liked the talk and got a glimpse of how privacy and trust by design works and what opportunities for your business opens up with these new technologies. And I will give back the floor to Nina. Thanks.
Thanks a lot, Lukas. I actually love it, so thank you very much. So I will share my screen again. Go into full screen again. I hope everyone can see it now. Because right now we actually arrived already at our question and answer session, and I would like to encourage you to ask even the smallest aspects about the presented contents. Maybe you are dealing with similar things in your work environment, so we would really love to receive your questions here. We have a questions section which you can use, and I think it should also be possible to just unmute yourself and speak up if you want to raise a question. Either way in which you feel fine, we are happy to take your questions now. Maybe for clarification, have you all seen the questions section here in GoToWebinar? Maybe you can give me a short feedback in chat. So I dropped a message for you, for all the participants right now in the chat. Maybe you could give me a short feedback whether you see the question section or not, because then we would have to fix it. Okay, Robert Redl, yes, okay, it works. So there's also the first question. Which are the main challenges when applying MPC? I think this question goes directly to you, Lukas.
So currently we have two major challenges. The technology is kind of the transition between research and business ready. So we have to find software developers that understand enough from cryptography to develop our technology further so that it can be easily used. And that's also what we're doing in Trust. So we want the technology to be ready in Trust so that you can use it without having any background, but just as any API or any software we would use, you can just plug it in. And secondly, if this deals with a lot of data, then the performance could be an issue. But if this private sector intersection, we don't have any performance issues. But if you, for example, want to do this a more complicated, so let's say train a neural network with MPC, then you could run into performance issues. But also there's a lot of going on in the research to get things faster.
Thanks. I hope, David, that this answered your question. If there are any additional questions, again, now you see how the system works, just drop them there. I will give you a few minutes if you need to type them in.
Nina, could I just elaborate a bit from the business perspective? I think Lukas gave a clear point of view on the offering of the application. Another challenge is on the user perspective. Usability is straightforward through the implementation of our colleagues in Know. But we have to take also into account the businesses. So banks, telco operators, and other things, and other enterprises would like to have a reassurance that everything is working well, the cryptography algorithms and implementation are compliant. So if there are consistent processes, for instance, if PSI or other applications are offered through a trusted environment, such a data marketplace that follows all the processes, GDPR, inspection of security leaks, and so on and so forth, this will increase the trust in order to use the specific implementation. So directions towards standardizing and inspecting such software and such applications are very useful in order to be accommodated in every business process. Thank you.
Thank you, Ioannis. Great extension. Thanks a lot.
Thank you, Ioannis. And I just want to short reply to that. So that's exactly what we as developers want to do in TRUSTS. So in Safety, it was the first time we developed this protocol and it was a proof of concept. But now in TRUSTS, we want to have to step a level up and exactly match the needs what Ioannis told you now.
Great. Thanks, Lukas. So maybe these added questions. Yes, we have one additional question. Are there MPC applications already in business, or is it still a research topic?
No, they are already in business. So there's one big business where you have, I don't know if you're familiar, you have to store on the server the keys. So for the TLS connection and so on, and usually this is done in hardware, and this special hardware costs a lot of money. And there you can, with MPC, distribute the trust to different servers, and then there is no need for such a special hardware anymore. But the even more interesting part is, for example, Facebook is now experimenting it and using it for their ad subscriptions. So they want to measure how users, so they show you an ad and then they want to measure, okay, did the user buy this this product? And they do this with a bit of a version of this PSI, this private set intersection, which I showed you, to have it in a more privacy preserving way. And why are they doing this? Because they are being forced from the EU and the GDPR to consider privacy preserving solutions if they exist. And now, since they are, as you saw, in existence, they push further to develop to use it also in their business model. But there are many more. This is my prime example with Facebook.
Okay, great. Thanks, Lukas. There came one question in additionally. Are there any open source tools or implementations in data management software already offered based on MPC for own project usage?
Okay, could you maybe clarify what data management software, what are you thinking in this direction?
Yes, the question comes from Claire Jean Cartier. Maybe Claire, could you clarify what data management software you were speaking of, or did you just mean it in general? General tools also. So maybe Alexandros and Lukas, you could just elaborate a little bit on the question in a general sense.
Yeah, for MPC, I would say there are libraries, a lot of them. Most are based on C++ that you can use, and some are in Java. So we're also using in safety in another use case a Java library to develop MPC protocols, because usually it is a bit faster to develop projects in Java than in C++. But that's also kind of an issue that we have now to integrate it in these data management softwares. And in Trust, we're aiming for a Dockerized solution, so it is very easy to download it and integrate it into your software environment.
With regards to anonymization tools, there exists at least there are many tools, like 6 or 7, but one of them is state of the art. It's called ARX, and what we are doing in Trust is actually address the limitation that it has, and these limitations specifically are they are not able to deal with complex high-dimensional data in either the anonymization risk analysis or anonymization, and this is what we are working on in the Trust project.
Great, thank you. Clear answers, great, perfect, thank you. Okay, we still have a few minutes for questions. So feel free to just drop everything you want to know about anonymization, about MPC. I will give you a few minutes more because typing takes time sometimes. I hear somebody typing, but I'm not sure who that is. Okay, Lukas dropped the MPC Java framework, but I think, Lukas, you have to drop it into the chat, but let me do that so that everyone can see. That's the MPC Java framework. Yes. Maybe you could give a short feedback if you see the link shared by me from Lukas. The MPC Java framework. I just want to make sure that you see this link because it might be of use for some of you. Visible. Thanks, Claire. Well, since no additional questions arose, I would say we proceed with the closing. I would like to invite you to our network. I mean, on the one side to the Safety network, we have the professional partners community here, where slides are missing now. Okay, so in Safety, you can benefit from an exchange with the consortium of Safety. You can also test through very early technology setups. So make sure you check out the Safety PPC, which you can find on the website of Safety. You can register there directly, and the Safety Consortium will get into contact with you afterwards. Also, I would like to invite you to the TRUSTS network. We have on the one side a stakeholder advisory board where we would like to get in exchange with people who are also active in the domain, who are experts or at least have extensive knowledge on the field of data markets and what could be challenges, what could be possible solutions to challenges, and so on. Also, we have a meetup network in Trusts where we just organize events together to extend the network, to get in exchange with other members of the data community within Europe, because we are very sure that this exchange is necessary for all of us and that we can all benefit from it. I will for now share the link from Safety again with you, or the PPC, if it works. And if you want to get part of Trust, please contact me directly via my email, which I will also type into the chat. It's nina.popanton@dataintelligence.at. Please make sure you keep in touch with us. Also, I would like you to save the date for our next webinar, because this was only the second of 3 webinar sessions together with Safety and Trusts. The next one will be on the business aspects, and it will be on May 10th at 11 a.m. Central European Summer Time. Okay, here again the information on Safety Professional Partners Community. Here we have the link, now it works. And here is also some information on the TRUSTS SAB and on the TRUSTS Meetup Network. As I said, please make sure you contact me directly. I'm very looking forward to receive your messages. So, and that is already the end of today's webinar. I thank you all for your participation. Thank you for actively engaged via the questions section. And I hope to see you next time on the 10th of May. Thank you.
Thank you. Bye-bye.
Thank you, everyone. Bye-bye.